Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is today's very hard puzzle. And it's called Elementary by Mad Tyus. And here are the rules. We have Sudoku, where we need to fill every row, column, and marked 3x3 box with the digits 1 through 9. We have fire and water cells. There are 9 fire cells in the grid, exactly 1 in every row, column, we can get that too, and a marked 3x3 box, and filled with a complete set of the digits 1 through 9. There are also 9 water cells following the same rules as the fire cells, and it is possible for a cell to belong to both sets simultaneously. The value of fire and water cells is the digit in the cell multiplied with the minimum number of orthogonal steps between the fire cell and the water cell within the respective marked 3x3 box. If a cell is fire and water at the same time, its value is 0, because the minimum number of orthogonal steps is 0. Note, as the same rules apply to the set of fire cells and the set of water cells, it's not possible or required to decide which of the sets is fire and which is water. So, for example, basically, if the fire and water cell were the same cell, it would have a value of 0. If the fire cell were here and the water cell were here, the values of the cell would be the digit in the cell multiplied with the minimum number of orthogonal steps between the fire and water cell, which in this case would be 1, 2, 3, 4. So if this is the maximum you could have, then the value of this cell is whatever digit is in it times 4, because that's the minimum amount of orthogonal steps it takes to get from the fire to the water cell. And finally, this is important because we have Nabner lines, where each value on the golden line must differ by 2 or more from each other value on the same line. So that's why we have fire and water here, which is very important for this very long line. Because if we don't have fire and water, well, guess what? If you have 5 digits on the, if you have 6 digits on this Nabner line, you are guaranteed, if there are no fire or water cells on there, you're guaranteed some digit is going to be differing from another value on the line by less than 2, right? Because you only have without fire and water, you only have the values 1 through 9, and that's it. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, how long are these Nabner lines? We have 1, 2, 3, 4, 5, 6, 7. Okay. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 15 values here. That means they're going to have a difference of from 0. You have 0, 0, 2, 4, 6, 8. 10, 12, 14, 16, 18, up to 28. So there's a difference of at least 28 from the lowest digit on this line to the highest digit on this line. At least 28. Another question is how many fire and water cells do we have available on this set? Well, we only have the digits 1, 3. We have, at most, we can only have 5 non-fire water cells on this Nabner line. Well, we have guaranteed 1 here, guaranteed 2 here, 3 here, 4 here. So we have a guaranteed 4 non-fire water cells on this line. Okay. Um hmm. The interesting thing is, though, if you have 4 away, what are those values? You could only have... You can't have repeats. So 4 away on a Nabner line for the fire and water cells. Okay, yeah, let's mark what are the values okay, so there's 0. You have 1 through 9. For for a step that's 2 away, 1 away doesn't help at all. 2 away gives you the potential of 10, 12, 14, 16, and 18. 3 gives you 3 away gives you 15. Actually gives you also 12, but that's not how we want the difference ones. 15, 18. 18 doesn't help. 21, 24, and 27. And 4 away gives you 20, 20, 24, which is already given, 28, 32, and 36. Okay. That's not many. So we have what, 16 values here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We can have at most 5 here. 0, 2, 4, 6, 8. And then another 5 here. 10, 12, 14, 16, 18. 20, 24, 28, 32, and 36. Right. So don't the values have to be okay? So if we try to have 1, 3, 5, 7, 9, I don't think that works, right? If we have 1, 3, 5, 7, 9, okay. If we have 1, 3, 5, 7, 9, the only way does that even work? 1, 3, 5, 7, 9 eliminates 10 as a possibility. 15 would eliminate 14 and 16 as possibilities. So we would have, that would limit us more if we had 15. So we'd have 12, 14, 16, 18. That would give us 9 values. 21 would, we either choose 20 or 21. We either choose 24, you have fine, 27 or 28. And then, so the problem is that's 9. We add one for 2021. We have 24. 27, 28 is 1. And then 32 and 36, which is too small. So I think it has to be 0, 2, 4, 6, 8, and then 10. Because 1, 3, 5, 7, 9 eliminates the value of 10, possibly. And then we don't have enough values. So I think the values right now have to be for the 15 line. It's 0, 2, 4, 6, 8. So we have 0, 2, 4, 6, and 8. We have 10. We cannot get 15, so 12 works. 14, 16, that's 9 values. 18, we have 1 out of 20 or 21. 20 or 21. We have 24, 1 out of 27 or 28. And then we have 32 and 36. And that gives us the 15 values. So we need a 0. We need 2, 4, 6, and 8. So we have all the non-fire and water cells known. It's going to be in boxes 1, 2, 4, and 8, which means the rest are all fire and water cells, right? Because we have all of them accounted for. We have 2, 4, 6, 8 as the only non-fire and water cells. I guess let's move it over. Well, that's not helpful. So we have 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 or 21, 24, 27 or 28, 32, and then 36. Those are what we are guaranteed to have. So we have to have 2, and this is some combination of those, right? We have to have 2 that are 4 apart, guaranteed. So we know these are not the water and fire cells in that box. That's 2 away. So none of these can be fire or water. None of these can be fire or water in remaining in these boxes. So none of these can be fire or water. None of these can be fire or water. None of these can be fire or water. And only one of these could be fire or water here. So this can't be fire or water. That's interesting. We have 1, 2, 3, 4, 5, 6, 7. Um, we can only have 5 normal values at most. Well, we could have 2 here. Okay. One of them is going to have to be doubled, which is 0. And it cannot be any of these cells. So I think this is the only one that this has to be fire and water, which means it has value 0. So this cannot be. That means in the rest of this row, there cannot be fire and water, which means these are a fire-water combination, and this is a fire-water combination. So one of these is going to have to be 28 or 20 with 24. The other one's going to be 32 with 36. So this is fire, water, this is fire, water, this is fire, water. We need a 3 away for the 18. This fire and water eliminates fire and water in the rest of the column also. So this is value 0. We're going to have 1 out of 28. This is guaranteed to be 2 away. Oh, we only have so many accesses to 8 and 9 also. Oh, we don't necessarily need the 3 away. This is interesting. That's 4 distinct digits which cannot be fire and water. So it's like some combination of, right? This is not fire or water. Neither is this. So we have what? These again are 7 values. For the one that's 3, we are guaranteed. Well, these two have to be fire and water. I don't really know which one we choose for each. Guess let's make that red and that blue. It doesn't really matter. The red has to be one of these, which makes that blue, which makes that red. So then that's blue, which makes that red. This has to be blue. So this cannot be blue here. And again, these can't be both because that's only a orthogonal distance of 1. So that would have the same value. So therefore, we're guaranteed this has to be red. One of these is blue. So one of these is red, one of these is blue. We have a guaranteed red in one of those 3 cells. What else do we have? Hmm. So we need 10. We definitely need 10. We need 12. So we need 10 and we need 14. And those are guaranteed by 2 away. But we don't have any other guaranteed 2 aparts from each other. Interesting. Hmm. The rest of row 8 cannot have a fire and water. Okay. We know red is one of these 2. Okay, the rest of column 4 does not have fire and water. We have a fire and a water guaranteed there. Um, um, hmm. Um, hmm. We have a guaranteed blue here and a guaranteed red here and a guaranteed blue here. Hmm. Okay. We have guaranteed 32 and 36. That takes out an 8 and a 9 guaranteed. Hmm. I need to pause because I need to go to the bathroom. I will be right back. And I'm back. Okay, let's continue. So, hmm. Um, we obviously don't have access to 32 and 36. Well, this is 2 away. You could have multiple 3-aways, though, here. Hmm. Could you have another 2-away, though? You can't have 4 2-aways. Or, sorry, you can't have both of these be 2-away. Because if that were the case, okay, let's take a look at what that would mean. You'd have red and blue here. The problem is 2-away here, 2-away here, 2-away here. That means there are 6 values there. And you'd have 18 at most, 16, 14, 12, 10, but then an 8 would have to be there. And that's not going to happen. So one of them has to be at least a 3-away. You could have multiple 3-aways. Can you? Multiple so for the 2-aways, you have you have to have 10 and 14 guaranteed. If you don't have those, you're not going to have enough different values. If you have the 4, you could have 3 and 4 be 4-away, which would multiply to 12 and 16. So that could work. And then if you have 2 sets of 3-aways, you could have 18, 21, 24, and 27, and that would work. So if you have 2 sets of 3-aways, that would have to be 18, 21, 24, and 27. Which is 6, 7, 8, and 9 times 3. That would work. Can you have 2 sets of 2 and then a set of 3? If you have 2 sets of 2, that takes out 12 and 16 as a possibility for the sets of 4 that are the fire and water that are 4 apart. If you have fire and water that are 4 apart, it would have to be then 32, 36, 28, and 20. Because we can't get 20. Well, we could get 24. Well, if you have 2 sets of 4 that are 2 apart, you're guaranteed you have to have 10 and 14. Which means a 5 and a 7 are definite. For the 4 parts, you're guaranteed 32 and 36, which are 8 and 9. So 1 out of 8 or 9 is not going to be available. Because you could have 12 with 16. If you try to use 16 and 18, does that work? So if you have 8 and 9, 16 and 18, 3, you don't have 3 times 8 or 3 times 9 available anymore. I guess, yeah, you have to take this into account with the other digits. Let's figure out also The digits that are available for the fire and water that are non-zero. We have 5, 6, 7, 8, 9 for the 2s. For the 3s, what do we have available? 3 times 3 does not work. 4, we have 4 through 9. And for 4 away, we have 3, 4, 5, 6, 7, 8, 9. Those are all the possible different values you can have when multiplied um, by the orthogonal steps away. So we're guaranteed this is both. That's 2 digits there. So it cannot be 5, 7, 8, or 9. It could potentially be 6. Very unlikely. It's probably 1 or 2 would be my guess. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits in fire and water. We have guaranteed at least 2 here on this line. So that's 12 digits already. How many digits in total do we have? 18. So that doesn't help us too much. Okay. This is at most 3 away. This is at most 3 away. So we do not have available 4 ways for either of these. That's interesting. Hmm. What else do we have available? Um, hmm. Oh. It's not that restrictive as I thought it would be. So again, if we have the sets of 3-digit number or 3-aways, we have 4 of those. I guess you could have 12, right? 12, 18. One of them's guaranteed to be 21 and 24. That's not that restrictive either. Hmm. Hmm. Well, we know one of these at least has to be 3 apart. And that doesn't really help us too much, but we do know that. It could be both of them. So what happens if it's both of them? Okay, so then you have blue here. This would be red. So red would be one of these two. Blue would be one of these two. None of these could be fire or water. So we'd have these 5 digits here, which would be 13579. This would then have to be red, and we'd have to have blue there. And then this would have to be a red or blue. Could not be red because of red in the row, so this is blue. These are not fire or water. This can't be fire or water. This can't be fire or water. Blue cannot be here, so blue would have to be here guaranteed. We don't know where red would be. Red could be here or here. We don't know. So this would have to be 1, 3, 5, 7, and 9. Red 2 away. Blue would have to be at least 2 away from here also. At least. Huh. Does that work? Is what I'm thinking of. So it'd be 1, 3, 5, 7, 9. For 2 away, it would not be 5. So it would have to be 6, 7, 8, or 9 here. This would be 1, 3, 5, 7, 9 here as a set. Huh. Yeah, it couldn't be 10 in value here. This could be 3 away. So we don't know. It can't be 3. It could be 2 times 4, actually. That would be fine. This would have to be a 5, 7 pair here to get the multiply to 10 and 14, which we have to have available. I was hoping it would restrict something, but it doesn't seem to be. Uh-huh. Hmm. Oops, sorry. Apologies. That probably shook the camera there. Um, I was really hoping that this would restrict things, but it's not seeming to. These would obviously be 2, 4, 6, and 8, different ones for the non-fire water cells. Well, that doesn't really help us much. This digit could not be any of these digits, could not be any of the digits on the Nabner line, so it would have to be one of these three. Therefore, it would force to be one of those three. That's not helpful. Yeah, so we've mapped out a decent amount of this, but the problem is I'm not sure what the sets in box 4 and box 8 are like. One of them has to be 3 apart. The question is, do both of them have to be 3 apart? Hmm. Oh, interesting. Oh, no, never mind. Blue could be over here, right? And then I was thinking that this actually cannot be 3 apart from each other, but they could be. You could have blue here and then red there to be 3 apart. That would work fine. Hmm. Hmm. So the question becomes, how do we how do we figure out which path this has to go down, or does it? Uh no, we know there's an 8 and so this has to, well, we don't know if this one specifically is a 5-7 pair. Right. Um hmm. Hmm. Uh, hmm. Hmm. Okay, so what happens if we have 6, 7, 8, 9 for the 4-part ones? That would mean we have 24, 28, 32, and 36 in value. We can never have 9 away. That's 3 apart. Um, we would have to have an 18 somewhere. That's not helpful either. seems like it's pretty wide open right now still. Um, that's why I was hoping that the three aways would lead to a contradiction so that we could get some more information there. But so far, that's not leading to anything. Um, hmm. Well, okay, so this can't be red or blue because it sees a red in the column and a blue in the row. So that's helpful. Doesn't this always have to be red? I guess you could have blue here and red there, right? That is possible. Hmm. Can red be here? Um, Blue can't be there, so blue wouldn't be here. So then blue would be here. Okay. If we had red here and this was blue, red, that means this couldn't be red anymore. So this would have to be red. And this would have to be, for this to work, we would guaranteed, one of these is guaranteed to be fire or water. At least two orthogonal steps away from the other one. So it would be that way. That would force this not to be blue, and then this would be blue, and we'd have a contradiction. So this cannot be red here. So red has to be one of these two. Can it really be here? That seems weird, but possibly. Red here, blue here. That would force red to be here. You'd have blue there. Red would still be one of those. You'd have 1, 2, 3, 4, 5. So this would have to be blue. No blue here, no blue here or here. So blue would have to be there. That seems okay. Hmm. This would be 2 away. This would be 2 away. This would be 3 away. Hmm. So red could be there. So if this is red, this is blue. Red cannot be here. So red could be here. You could potentially have blue here. You could have blue here. What you cannot have is blue here because that would be 1 away from here, which would not give you a unique value. And if red were here, it would be value of 0, and then these would all be non-fire and water values, which means we would have 6 of them, which is not possible. So red has to be one of these 2. Blue has to be one of these 3 guaranteed. Blue can't be here because of blue in the row. So one of these is red, one of these 3 is blue, obviously. One of these 2 is red here. One of these 2 is blue here. We need one of these 2 is blue, one of these 2 is red here. Blue has to be one of these 4. Red can be any of these 6, so that's not too helpful. Hmm. Uh, um, hmm. This is the tough part of it. I feel like the first part is fairly straightforward with how long the long Nabner line is. But trying to decipher how it finally breaks apart is a little troublesome. Um, hmm. Hmm. If you have two sets of three that are two sets that are three apart from each other, you would only have available 12, 18, 21, 24, or 27. Hmm. Um, let's try to work through what happens there again. Okay, so say we have two sets of three. There are two sets that are three apart from each other. That would eliminate blue here. That would eliminate red here. So these would all be gray. These would have to be gray. We'd have red here, so this would guaranteed have to be blue. So you could not have blue there. No red here. These are not anything. This is not anything. Okay, what are the possible combinations we can have for the threes? You would again, you could have 4, 6, 7, 8, and 9. Okay. Say you had 6, 7, 8, 9. That would give you value of 18, 21, 24, and 27. That means the four times values would have to be 12 and 16. So we'd have 5 and 7 here. These would have to be 3, 4, 8, and 9. And so we'd have the three aways would be 6 through 9. Okay. So the 7s would not be available anymore. 8 and 9 would not be available anymore. This would also have to be 6 through 9. Hmm. This could be 3 away, so this would have to be 4 through 9. Hmm. So you'd have 10, 12, 14, 16, 18 all available. um, these would have to be 1, 3, 5, 7, 9 here. But that doesn't really help us much. Hmm. Okay. One, two, three, four, five, six. 1, 2, 3, 4, 5, 6. Hmm. Mm, hmm. I mean, that seems fine. Oh, wait. Hold up. Okay, so 7, 8, 9 would not be available here. Because again, the three sets, we're assuming that it's 6, 7, 8, 9, right? We have all the 7s taken out, all the 8 and 9s taken out from the sets that are 3 apart, and then the 2 apart for the 7s, and then the 4 parts for the 8 and 9. So therefore, this would have to be a 6, which would be 12. So even if this were 3 apart, you could not have a 4 there. So this would have to be 5, 6, 7, 8, or 9. The 6 would eliminate 6 as a possibility for the red cells. So we'd have 7, 8, 9 there. Therefore, this digit, what could it be? So it wouldn't have 6 available, no 7, 8, or 9 available either. So that would force this to be 5, which would make this 7, this 5. No more 7s in red. So this would not be 7. We need a 7 in 5 and 7 would eliminate 5 and 7 here. We need a 7 used in the blues. So this would be 7 then here. 8 and 9s would be in both of the reds, so that eliminates 8 and 9 in the rest of the reds. This cannot be 8 and 9, it's 3, 4. This cannot be 8 and 9, it's 3, 4. That eliminates 3, 4 in the rest of the blues. But then we have an 8 and 9 pair in the blues, and that would force this to be 6, but we already have a 6 in the row there. So it cannot be 6, 7, 8, and 9. If we have triplet, if we have 3 apart, if we have 2 sets that are 3 apart from each other. That leaves us 4 with something. What happens if we try 4, 7, 8, 9? What does that leave us then? 4, 7, 8, 9. 4 times 3 away would be 12. 4, 7, 8, 9 would give us 21, 24, 27. That does not work. So we are guaranteed we have to have 6. So that means, okay. We are guaranteed we have to have 6 with it to give us the 18 if there are two sets that are 3 apart here. Because otherwise we don't get an access to an 18. If it's 2 apart, well, we don't have a guarantee. So we have 4 times 3, which is 12 here. So this cannot be then 3 here. We don't have access to 16 except for the 4 times 4 part. So we're guaranteed a 4 here. We're guaranteed a 4 in one of these. That's interesting. So that means we cannot have 4 available in any of the sets. Any other of the sets. So this cannot be 4. So what happens if we do 4, 6, 8, 9? Okay, let's try that. 4, 6, 8, 9 means no 7 here, no 7 here, no 7 here, no 7 here. That means we have used what is 4, 6, 8, 9 times 3? 4 times 3 is 12. 6 times 3 is 18. Then we have 24 and 27. So we would need 4 times 5 to multiply to 20, so this would be a 4-5 combination, which means we don't have 5 available at all anymore. So this has to be 6 through 9 here also. Again, 4, 6, 8, 9 eliminates 8 and 9 in both reds and blues. So this is a 6, 7 pair. Huh. If this is 7, that would force this to be 5. That seems okay. So what happens if this is 6 here? No 6s here, here for the reds. It would have to be in the blue here. So therefore, this would be 7. That would force this to be 5. That would force that to be 7. And that's a contradiction because the blues then have multiple 7s in them. Oh, that's actually very interesting. What happens if this is 7? If this is 7, this becomes 5. That's 7 there. We do not have 7s available in the blue, so this becomes 6, which means we do not have 6s available in blues either. So one of the reds is a 6. 5 is no longer available in the reds. So one of these would be 5 here. 7 would eliminate 7 in all of these cells. That's interesting. That would force this to be 7 there. Okay. This would be value 14 to be 2 away. We have 1, 3, 5, 7, 9 here. That means 7 could not be here or here. It can't be here because of 7 in the column, so 7 would have to be there. So far, that's looking okay. We have a 4, 5, 8, 9 quadruplet in the blue set. That's fine, though. That seems fine. So that seems to work okay. So if it's 4, 6, 8, 9, this has to be 7. But that seems fine. Hmm. Okay. Hmm. Okay. So that's if we assume 4, 6, 8, 9. What happens if we have 4, 6, 7, 9 that are 3 apart? What does that give us? Well, we don't have access to 7 anymore for the 4 apart. Okay, so 4 gives us 4 times 3 is 12. 3 times 6 is 18. 3 times 7 is 21. And 3 times 9 is 27. Okay, 4, 6, 7, 8 does not work. I can tell you immediately. If we have 4, 6, 7, 8 as the 3 parts, the problem with that is we don't have access to the 7s anymore because we're guaranteed a 7 in one of red or blue here. We're guaranteed a 7 in this pair. So, and the values would be 4 times 3, which is 12, 6 times 3, which is 18, 7 times 3, which is 21, and 8 times 3, which is 24. But to try to get to, we need one out of 27 or 28, but that would require 7 times 4. So that does not work. 4, 6, 7, 9, though, might. 4, 6, 7, 9 gives us 12, 18, 21, and 27 in value. So we need 24, and we need 16. So it's 4, 6, 8, and 9 for the 4 apart from each other. So that means we have 7 already counted twice in the fire and water, 6 already counted twice in the fire and water, 9 accounted twice in the fire and water, and this then has to be 8. So this is 8, which eliminates 8 from the rest of the fire cells, or the red cells. So it's 8 times 2, which is fine. This is still 1, 3, 5, 7, 9 here. Okay. This could be 4 still. 4, 5. We do have 4 and 5 available. We do not have 6, 7, 9, and now no longer 8. So this is 4 or 5, which means it cannot be 2 apart, which means red would have to go here. This would be medium. This would then be not red, so that would be 1 apart from each other. Oh, this is already 4 twice. So then this would have to be 5. Ah, but that doesn't work. Because to be 2 or more away from 1, 3, 5, 7, 9, it can't be 5 times 2, because that would be 10. But this would be 5 times 3, which would be 15. And that's 1 away from 2 times 8, which is 16. So that does not work. So the only way that this works is the only way 2 sets of 3 apart work is if they are 4, 6, 8, 9. And then this has to be 7. Okay. Hmm. Okay. Um. Hmm. Curious. Should we try to go down this path? Mm. This did seem like it seemed to work. Okay, so 7 here, that forces this to be 7 there, because these cannot be 7. This can't be 1, 3, 5, 7, 9. It's 2, 4, 6, 8. 7 means this can't be 7 here, so that's 5 and 7 there. Again, for 4, 6, 8, 9, we have 12 counted for 18, 24, 27, which means we need 5 times 4 and 4 times 4. So this becomes 4, 5, 8, 9. No 5s in the red cells, so 4, 8, 9. 4, 5, 8, 9. This digit. Oh, wait. It has to be 6. And that's fine for either one. Okay. That means this digit cannot be 6, 4, 6, or 8. It has to be 2. And the reason is because 6 is already accounted for in one of these sets of 3. So 6 there, no 6 in the blues. This is 4, 5, 8, 9. So 6 is in one of the reds. We have 2 here, which means this can't be 2. Seems fine. Hmm. I mean, that seems fine. This specifically has to be 4, 6, 8 in that instance. But that's fine. This is 4, 6, 8. Oh, that's interesting. We have a 4, 6, 8 triplet in column. This would have to be 7. Interesting. Right, remember this would still be 2, 4, 6, 8. We'd have 2, 4, 6, 8 here. This could not be 2. It would be 1 or 3. But that doesn't really preclude very much. This can't be 5 because we know one of these is guaranteed to be a 5. So we'd have to have 5 be here. Okay. Seems fine. Hmm. One of these is a 2, but we don't know. So the question is, can these be... Okay, so no 7 here. Okay. That seems fine. Okay, let's delete all this because we don't need that for now. Uh, hmm. So 7 would have to be one of these two. 7 would have to be one of those two. 7 would be one of these two, so 7 would have to be one of those two there. Hmm. Hmm. This all seems fine. It would if these were combinations, it would have to be 1, 3, 5, 9 if they were all if they were all odd. But you could have combinations with like 1, 3, 6 with 8 or 1, 3, 6 with 9, 9 with yeah. So that doesn't seem to be very restrictive. Okay, what else can we go through? So if we have two sets of three, we know they have to be 4, 6, 8, 9. Otherwise, what can they be? Well, let's try red here. Which means this can't be red, so this would still be red. We have no red here. This would be gray. This would have to be 2 blue. So this would be gray here. So this would be lead to something similar. This would be blue, no blue here. We'd still have this scenario. So this would have to be blue here, which means no blue here. No blue here. So this is blue. We have blue here. One of these is red. Okay, so how does that work? Why did I delete the, I don't even understand. Okay. So this is 2 away. We could have 5 through 9 in the 2s. What happens if we do 5, 7, 8, 9? That might be very interesting. 5, 7, 8, 9 means we have values 10, 14, 16, and 18. Okay. We do not have 8 and 9 available for the 3s because they're taken up by the 4s and the 2s. So that means 24 and 27 are immediately not available. So for the 3s, the only possibility would be 4, 6, and 7 as possibilities. Okay. Okay, so what would we have available? We'd have 4, 6, and 7. So that would be, hold up, 5, 7, 8, and 9 means 6 would not be available here. Because 6 times 3 is 18, but we already have an 18 in the set of 2. In the sets that are 2 apart. So we need 12, we have 10, and we would have 21. That seems okay. Does it though? 4 times 3 is 12, but we already have that with the other 4 times. We have, sorry, 3 times 4 steps apart is already taken care of here by this 4, 7, because we don't have 8 and 9 available. 4 times 4 apart is taken by this 8 here. 4 times 5 is 20, but we already have 21 here, so that doesn't work. So 4 times 6 does work, but we don't have access to 7 times 4, which is a fail. So that does not work. So if we have 2 apart, we cannot have 5, 7, 8, 9. So that means we're guaranteed a 6. So 5, 6, 7, and 9 we'll try. 5, 6, 7, and 9 means we have 10, 12, 14, 18. We need the 16, which would guarantee a 4 for the 4 parts. We do not have 9 available times 3, so that means 27 doesn't work. So we would have to have 28 for that, for the 4s apart. So that's guaranteed 4, 7, 8, 9. So 7 times 3 would not be allowed. But then we need a 20 or a 21, and we don't have access to the 5, and we don't have access to this. Well, 5 times, we don't have access to 5 times 4. We don't have 7 available for this set either. So that would also fail. So what about 5, 6, 7, 8? So if we have 5, 6, 7, 8, that gives us 10, 12, 14, 16. We would still have 18 available, so it would be 3 times 6. So we'd guarantee a 6. So no more 6 times 4 is available. Aha, and there's the contradiction. So the contradiction was in that if we have one of them 2 apart from each other, it's just not going to work. So again, if you have 5, 6, 7, 8 for the 2 aparts, for the sets that are 2 apart, that gives you 10, 12, 14, 16. That means we have to get 18 with 6 times 3. But then that means we don't have access to 6 for the 4 aparts because we have guaranteed 6 in the 2 aparts, guaranteed 6 in the 3 aparts, and that accounts for all the 6s in red and blue. That means we don't have access to 6 times 4, which is 24. We don't have access to 8 times 3 because one of them's taken up by the 2 aparts and one of them's taken up by the 4 parts. And therefore, you cannot have 2 digits that are... We cannot have 2 sets that are 2 apart from each other. They are guaranteed, then, to be 3 apart in these sets. So this has to be blue here. Sorry, not blue. Red here. This is not a set. This is blue here, which means this is not a set, which means blue cannot be either of these. We need one digit that's not at least that is a fire or water here, which means it has to be here, which means this can't be fire or water. And this has to be 2 away from it for this to actually give you a value that's not 13579. Okay, so we've done all that. We can delete all this stuff because that's... Oops. So this is both fire and water. We know these are the set that we need 5 times 2 and 7 times 2 to give us 10 and 14, and those are the only ways to get it. We know This has to be 4, 6, 8. No. Yes, 4, 6, 8, 9, because that's the only combination that works for the 3 apart. So that gives us 4, 6, 8, 9. So it's 27, 24, 18, and 12. We need 16, so that would be 4 here. We do not have 21, so it has to be 4, 5, 8, 9 here. So again, 8 and 9 are removed as possibilities here. We tried to have a 6 here, that doesn't work. So this has to be 7 here as the red, which makes this 5, that makes this 7. None of these can be 7 for the normal cells on the Nabner, which means 7 has to be here. This must be blue. Blue cannot be here. So these are normal. These are normal. So blue has to be here. This can't be anything. Red is one of these, and then red has to be one of these. We don't know which. And this has to be 6 because we don't have 7, 8, 9 available, and 5 eliminates all possibility for that. And then 4, I guess it... No, 4 is already used up by the 4 sets that are 4 apart and the sets that are 2 apart. So that means this cannot be 6 here. This is 1, 3, 5, and 9. 5 cannot be in the reds. So it's in one of the blues. So it's either here or here, which means this cannot be 5. So we're guaranteed a 5 is here. Again, this cannot be 6 or 8. And it can't be 4 because 4s are already used by the 4 parts and the 3 parts. The 6s is here and then in the 3 parts. So therefore this can't be 6. It can't be 1, 3, 5, 9. It sees all of those digits on the Nabner line, and they have to be different here. So this cannot be odd. It can't be 4, 6, or 8. It's 2. That leaves this again as 1 or 3. This blue here has to be the other 1 or 3. Sorry, not the other 1 or 3. Actually, yes, it does have to be the other 1 or 3 here. Interesting. So 2 in the red cells has to be one of these or one of these. We're not sure which. This digit cannot... Okay, so these digits cannot be 1, 3, 5, or 9. So it's 4, 6, 8 here. This is 4, 6, 8 here. We have 4, 6, 8 here. This is 2, 4, 6, 8. We have 2, 4, 6, 8 here. Okay. That leaves the remaining digits in column 5 as 1, 3, 5, 9. Okay. This can't be 5 because of 5 in the row. Okay, so one of these two digits is a 2. So 1, 3, or 9 has to be one of these digits here. So this, okay, where is 7 in box 8? Again, it has to be here. 7 can't be here or here. It cannot be on the Nabner line. So it has to be one of those two. So we have 7 guaranteed here, 7 guaranteed here, and 7 guaranteed here. This can't be 7, so one of these two is 7. One of these 3 is a 7. So again, one of these two is a 2. So that means you cannot have a 2 here. You can't have a 2 here. 1, 3, 4, 6, 7, 8, 9. Same with this, except this could also be 5. But this can't be 5 because it sees both of these 5s. 1, 3, 4, 5, 6, 7, 8, 9. And this can't be 5. This digit cannot be 5 because one of these 2 is a 5. One of these 2 is a 6, so this cannot be 2, 1, 2, 3, 2, 5, or 7, or 6. So 1, 3, 4, 8, and 9 are possibilities. Okay, so this digit is the same as that one. So this is A. We'll mark it as A. That's A. One of those two must be A. So these are all satisfied. This is 14. This is either 12 or 18. And we have 1, 3, 5, 7, 9 on the rest of this Nabner. Okay. This still could be 1, 3, 5, 9. That seems fine. One of them is going to have to be an 8 or 9 on there. Because we know we don't have a 7 there. So we have 1 out of 8 or 9. 1 out of 1 or 2. 1 out of 3 or 4. And 1 out of 5 or 6 on this line. But that doesn't really restrict us very much, so... no 5 here. So 1, 3, 4, 6, 8, or 9 is possible here. Interesting. Hmm. If this is red, that means this is also, these are both blue and red. And wait. Hold up, this is not A. Never mind, there is no A. This has to be the other one. Right. This is still the same. 1, 3, 4, 6, 8, 9. But this has to be the other digit. So if we had a red here, this would be one digit being one color, one digit being both colors, and the other digit being the other color. And then this would have to be 2, which could work. 2 times 2 is 4. And then these would have to be different, not 3 or 5, essentially, in value. Seems okay. Remaining digits in row 7, we have 1, 2, 3, 4, 8, 9. Okay. Um, hmm. If this were red, that means we'd have a red here. That would not work. So if we have red here, that means red is here. But the problem is, whatever this digit is, this has to be a different digit, but it still needs to be in a red somewhere. And then this blue would see both of these reds, and those are the only reds available. So you cannot have red be here. Therefore, the red has to be here, which means this can't be red. This is a combination that's both. So these are a 1-3 pair, which does force this to be 2 here. That eliminates 2 in the rest of the box. And this has to be, this is 4 here. This is 12 that way. This cannot be 3 and 5. Okay. So we have 1 available, no 2. Cannot be 4 either, because 4 would be 0 away from 4. 2 times 2. So we don't have 3, 4, 5, no 6, 7, 1, 8, or 9 as a combination here. Interesting. So these digits cannot be 1 or 3 because they see both of these cells. So it has to be 2, 4, 5, 6, 8, or 9. No 2 here, obviously, because of 2 in the row. It cannot be 8 and 9 here. So one of these is guaranteed to be a 1, which means that eliminates 1 from the rest of the box. That's all that really does. So 3, 4, 5, 8, 9 are the other possibilities. Okay. These cannot be 1 or 3, also for the same reason. So this has to be 2, 4, 5, 6, 7, 8, and 9. 7 cannot be these two cells because the 7 in row 3 has to be one of these two. Jeez. Pretty convoluted. Hmm. 6 also can't be here. But that doesn't really help us too much either. These 3 digits are distinct digits. So that means this digit is the 4th digit. And it must match this. And it cannot be 2 here. So where is the 2 value on this Nabner line? It has to be there. That's actually pretty fascinating there. That eliminates 2 in the rest of the row. We are guaranteed then a 2 in one of these 2 cells. Okay. Okay. That means this digit is the same as that digit. So now we can mark that as A. That doesn't really help us too much, but what are you gonna do? Okay. If this is 1, that would force this to be 3, which would force that to be 1. That could work. If this is 1, that forces this to be 3, which would force that to be 1. So 1 has to be one of these two cells, but that doesn't really tell us too much, unfortunately. Um, hmm. Um, hmm. 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 This is pretty difficult. Hmm. Hmm. I think 1 also has to be one of these two, right? If this is 1, so we know if this is 1, that's 3, which would force that to be 1. Otherwise, this is not 1, which would force that to be 1. So 1 has to be one of these two here also. Hmm. That doesn't really help us too much. So 6 has to be one of these 3. Ugh. Hmm. Uh, so again, we know one of these is a 5. One of these is a 6. Um, mm, 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 mm. Uh, what does this tell us? I don't really know. Um, mm. One thing we do know is we have two digits here that are both even. 4, 6, and 8, right? 2 out of 4, 6, or 8 are here. So that means they correspond to these two digits. So one that's here would have to be here, and then one of these 3. And the other one that's here would have to be one of these 3. But that doesn't narrow things down, unfortunately. Oh, 1359 all see these three cells here. So this cannot be 135 or 9 here. So there's no 9 here. These are non 1359, so they're even or they're 7. Interesting. Huh. That's interesting. This could be the same as A, or it could be something completely different. Where is 1, 3, or 9? It has to be one of these three here. It's also one of those three. We are guaranteed a 7 here. And then one even digit. So that makes 2 even digits here. There must be 2 other even digits here. And whatever odd digit is that's here has to be here. Okay. So we have 1, 3, or 9 here, and we have 2, 4, 6, 8 also as possibilities. Well, where's the 5 then? In box 8. It has to be here. Oh, that helps a lot. Okay. Well, that means this can no longer be 5. So 5 has to be one of these three guaranteed. Cannot be here because that sees one of the guaranteed 5s that's there. So 5 could be either here or here in column 4. 5 also eliminates possibilities for 5 here. Where's the 5 in box 9? It has to be here. That eliminates 5 in the rest of the column. So this can't be 5. That's helpful. Okay. So we have 2 even digits here. This is 1. And the last one has to be one of these 2. Okay. Huh. Okay. Hmm. 6 could be any of these 3. This digit cannot be the same as that. Can't be any of these 3. So this digit has to be one of these 2. If it's here, then it's guaranteed it's A. If it's here, we don't really know very much there. Uh, yeah. Hmm. Hmm. We know all four of these are distinct digits. We also know all four of these are distinct digits. That doesn't help us much. Oh boy. This is why it's very hard here. We have to figure out the logic behind this. And it's quite challenging here. Hmm. What happens if this is 5? Well, then that means you don't have 4 and 6 available. You would have to have 3. So it would have to be 1, 3 with 1 out of 8 or 9 here, if this were 5. If this were 5, though, that means you couldn't. Well, 5 could still be here. That's not that restrictive as I thought. Do we have anything else? I don't think so. By 2. Yeah. 14 and 12, which is 2 apart from each other. 12 is 3 apart from 9. And we have 1, 5, 1, 3, 5, 7, and 9 on this Nabner line. Remaining digits in row 8, we have 1, 2, 3, 4, 6, 8, 9. Okay, this can't be 6 because of 6 in... It has to be one of these two spots. This can't be 2 because of 2 in the column. Oh, interesting. So one of these is guaranteed to be a 2. Obviously, one of these is 3 is a 2. Hmm. This is pretty still varied. Okay, where is 3 in row 9? Can't be any of these digits here because of the way that the Nabner line works. Can't be here because of the way that these have to work out. So 3 is guaranteed to be one of these 3 cells, which means none of these can be 3. That's interesting. Okay. Hmm. boy. So this digit, A, has to be in one of these four cells because this is a 4, 6, 8, and 9 quadruplet, which are 3 apart, which gives us the different values. That means it cannot be this one. So this A has to be either here, here, or here. We don't know which. If A is here, it cannot be the red. It cannot be here. So you'd have A here, and A would then have to be there, which is possible. If A is here, that means A would have to be here. It could not be in the blue. It would have to be there. That's interesting. Or if A is here. Interesting. So it has to be in one of the reds here or in this blue. Huh. Hmm. A's here, that means A's there, which means A's one of those 3, which doesn't really help us much. Can A ever be here? If A is here, yeah, it could be one of those 2. Hmm. So A cannot be here or here. It's interesting, though. Hmm. Interesting. Okay. What happens if 2, where is 2 in box 2? It's either here or it's one of these 2. Say it's here. We know these are both even. One of these is guaranteed to be even, so this cannot be even here. And so for this Nabner line to work, it has to have a non-even digit, which means it would have to be 2 and 9 in that instance. And this would force this to be 4, 6 as a pair. Could that work? This would have to be 5 then, because we would have 4 even digits already. So this would be 5. There would be no 5 here. Okay, that seems doable. 4 and 6 would eliminate 4 and 6 here. It would be an 8 and 9 pair. Therefore, this would be 6, and this would be 4, which would make this 8. No 4. This would have to be 6 and 7 as a pair. No 4 or 6 here, so this would be 8. No 8 here. No 8 here because of 8 in the red cell, so that's 9. No 8 or 9, it's 4. That forces this 9 eliminates 9 here, so that's 8, which makes this 9. So no 4 or 8 here, it's 6, which makes this 6. This becomes 4 there, then. This has to be 9. So in this instance, this would be 1 or 3. So that's assuming that this was not 2. If this is 2, that would eliminate 2 here, and this would have to be 2. So this would be 1, 3 as a pair here. 2 is one of these two, and then this would be 1 or 3. So this has to be 1, 2, or 3 in this cell there. Okay, that's good to know. So this is guaranteed to be 1, 2, or 3 there. Because we tried when we we have a 2 here and not a 2 there. If we have a 2 here, then this is guaranteed to be 2. Otherwise, in that scenario, we had 2, 9 here. And that forces this to be 1, 3 here. Okay. Oh, in the scenario where this is not 2, that would mean this is 2, 9. This becomes 1, 3 as a pair. This is 4, 6 as a pair, which makes this an 8, 9 pair. So this can't be 8 or 9. It's 4 and 6 there. That forces this to be 8, and this has to be 6. So this can't ever be 4 or 8. It's either 2 here with the 7 or 6 here with the 7. Interesting. Hmm. 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 What other things do we have? Do we just have to go through every possibility? Ugh. That's not very pleasant. Hmm. Hmm. Uh, this is very complicated. Oh, where is this digit on in the blue cells? It sees that cell, and that cell, so it has to be here. So these are the same. So I guess we'll mark those as B. Oops. I don't know what just happened there. We'll mark those as B. And B can't be here. So this must be C, which means B has to be there. So this is not 6. B can't be here. B can't be here. It's one of these two. We don't know which, though. B can't be here. So B is in the red and the blue. We know B's here. B can't be there. B can't be here or here. B can't be here or here. Cannot be in the red, so it's one of these three. But that ain't helpful. C is... hmm. Well, that was interesting. Interesting. Um, hmm. Where is 6 in row 9 now? Can't be here. So it has to be one of these three, which eliminates 6 in the rest of the box. That's not that helpful, though. Man, this is complicated. Hmm. C has to be one of these three, but that's not that helpful. Uh, hmm. Um. Uh, hmm. Man, this is kind of painful. Hmm. Hmm. These are two even digits here, but that doesn't tell us enough. One of these is a 6. That doesn't help us. Trying to disambiguate all of these is very painful. Um, hmm. Hmm. A cannot be either of these. So A has to be one of these two. Wait, no, it could be that one. Never mind. Dang it. I don't know. Yeah. Hmm. Okay, let's fill this in. Maybe this will help. 1, 3, 4, 5, 7, 8, 9. Nope, didn't really help. Yeah, this part is the painful part. The logic behind the Nabner lines isn't too bad. The problem is trying to figure out where to go next after you've gotten all the values of the long Nabner line, right? Um, hmm. This digit has to be one of these two digits here. Yeah, but that doesn't tell us anything. So if hmm, so if we have even digits here, so what happens if this is 5? If we have 5 here, this has to be 5. This cannot be 5 here. We do not have. We have to have 1, 3, and 9. 1, 3, and 1 out of 8 or 9 here on this thing. Okay. That would mean 2 has to be here. No 2 here, which means 2 is there. That seems fine. 1, 3 with 1 out of 8 or 9. Two would have to be here. So this is a 2, 6 pair. Not 2, 6, a 2, 7 pair. And this would have to be 6 then, I think. Right. Because we have a 1, 3, 8, 9. 1, 3, 4, 8, 9 quintuplet in that case. That would force this to be 6. So there's no 6 here. Therefore, A is 4 or 8. That's interesting. Where's the 6 then? It has to be here, which makes that a 6 there. This can't be 6. So we'd guarantee one of these is a 9, so therefore this couldn't be 9. So this would be 4, 8, which would mean this would be A. A's here, A's here. A cannot be here, so A. This is 4, 8, 9 as a triplet here. We have A and B here, so that would force this to be 9, which means this could not be 9. So this would have to be A, and we'd have a contradiction. Okay. So, we know this can't be 5. Oh, that was a long, convoluted way of doing that. Anyways, this is 5. That eliminates 5 from being here. Um... Hmm. No 5 here, no 5 here, no 5... Well, 5 could be here, I guess. Um... This doesn't have 5, but this could have a 5 there. What happens if there's a 5 here? If there's a 5 there, this has to be some combination of 1, 3 with 8 and 9. Right? So we'd have the same scenario here. This would have to be 6. No 6 here. It's 2, 7 as a pair. Therefore, this is 2. Where is 6? It would have to be there. So this couldn't be 6 there, which would force this to be 6. So A could not be 6 here. I think it's a similar situation, right? This would be 1, 3, 4. So this would be 4 here. You'd make that 4 here. This would have to be 4, so it's B. That makes this 8. This can't be 4, 8. It's 9. This can't be 4, 9, so that would be 8. Oh, except that... oh, wait. Well, no, that still wouldn't work, because then 8 could not be any of these. 8 would have to be here, and we'd have a contradiction. So, what was that assumption? So that was assuming this was a 5, which means this can't be 5. Where is 5 in box 4? It has to be one of these two, which means this can't be 5 here. This can't be 5 either. That's not that helpful, though. This is very convoluted, it feels. B cannot be on this line. And B is 4 or 8. Um... This feels really convoluted. Okay. So we know we can't have a 5 on this, which means we have to have a 6 on this Nabner line. Okay. So there has to be a 6 in one of these 4 cells. But that doesn't really... If we have a 6 here, that would mean 6 has to be there. Otherwise, 6 is one of these two, which means this couldn't be 6. So 6 would have to be here. So, if we have a 6 here, that means this can't... Obviously, none of these could be 6. But if we have a 6 here, that means this can't be 6, so we need a 6 on this for the 3 set, the 3-step away, to multiply to 18. So either way, I don't think 6 can be here. Because we're guaranteed... 5 does not work for any of these. So 6 has to be on this Nabner. Otherwise, you'd have two digits from 1, 2, 3, 4, or 8, 9 being multiple times on this Nabner, or being on this Nabner, which would then be one apart from each other. So either this is 6, which means 6 can't be here, or 6 is here, which means 6 has to be here, which means 6. Sorry, if either have 6 here, eliminate 6 from the rest of this column. If we have 6 here, this can't be 6, so 6 has to be here for the 3 times 6 to multiply to 18, and therefore this can't be 6. So either way, this can't be 6. So A has to be a 6. Huh. Fascinating. Okay. So then C is the other 4, 8. Okay. So 6 cannot be here, cannot be there, can't be either of these cells, can't be here, can't be here either. We have 1 out of 3 or 4 on the Nabner, 1 out of 2 or 3 on the Nabner. Oh, this is a 4-8 pair here. So we can't have 4, 5, or 8. We have 1, 2, 3. No 4, 5, 7, or 8. Could be 6. Could be 9. So no 6 here. Okay. This is so convoluted. Okay. If this is 6, that means this can't be 6, so 6 has to be there. Otherwise, 6 has to be one of these two. And it can't be here, so 6 would have to be here either way. So either way, 6 in box 4 has to be there, which means this can't be 6, this can't be 6. Where is 6 in row 6 now? It has to be, it can't be here because one of these two has to be 6. Can't be here because 6 in the box. It has to be one of these two. So this becomes a 2-6 pair here. That's interesting, because those are the only places that can have 2 and 6 in row 6. That was interesting. Hmm. Oh, this has to be 2 or 6 here. That is interesting. You know this can't be 5 or 7. So, if this is 2, this is 2 and 9, and this would have to be 4 and 6 as a pair. If this is not 2, it's 6 here, which has to be with 1, 3, or 9. But it could be any of 1, 3, or 9. We could have 1, 3, 4, or 9 here. And that doesn't really help us much. Interesting. Not too helpful, but interesting. C also has to be one of these 3 cells. So B and C have to be here, which means this can't be B or C. It cannot be 4, 8. It's 6 or 9. So C has to be one of those 3 cells. C cannot be here, so C has to be one of these 2. We're not sure which. That's not too helpful. Oh boy. Whatever digit is here has to be the same as that. I guess we can mark that as Z. This digit has to be one of these three. And one of these three, but that's not too helpful. Um, oh, jeez. This is so convoluted. um, remaining digits here cannot be 2 or 6. 1, 3, 4, 5, 7, 8, 9. No 7 here, obviously. Oh, this is so painful just to try to solve this part. Oof. Still don't really see how that helps very much right now. Maybe it's something for the future. C is here. Well, C is one of these two. Never mind. We don't. Yeah, we don't have that much information. B cannot be here. Cannot be here. So C also has to be one of these two for the blues. And then we also have 9 there. If this is 9, that means 9 cannot be here. 9 has to be one of these 3 on the Nabner line, which means 9 cannot be any of these cells here. If this is not 9, this is 9, which means one of those 3. These can't be 9 here. Oh, that's interesting. So if this is 9, that means this can't be 9, so 9 has to be on the Nabner line, which means this can't be 9. If this is not 9, 9 is here, which means this cannot be 9 either way. So 9 cannot be here. Why did I get that Z? A Z was just here, right? Yeah. Hmm. If this is 2, no, that's fine. 2, 9, this becomes 4, 6. Yeah, that's fine. Hmm. Hmm. This Y is one of these 3. Oh. So this is a BCY triplet. Right? Y cannot be on the Nabner line. It has to be there. C and B both can't be here and here, so B have to be there. So that means Z has to be one of these 3. And this is X has to be one of those 3. So X is one of those 2. That ain't that helpful. Okay. Jeez, this is so convoluted. we know one of these two has to be a 9. Because if it's not a 9 here, well, yeah, you don't have 9 times 4 then anywhere on this Nabner line, which is necessary. So that eliminates 9 from the rest of the box. Does that help us any? I don't really know. I'm just getting, like, I don't know. I'm so confused right now. If this were 9, that means no 9 for the 3 set, so the 9 would have to be there. Oh, that's problematic. So say this was... Oh, no, that's if this is 9, not if this is 9. Never mind. Wait, can this ever be 8 here? I guess it could be 8. Ugh, okay. If this is 8, this cannot have a 9 here. So we'd have to have 1 out of 1 or 3 here with the 6. Man, this is so convoluted. This is so complex. This digit cannot be the same as these two. It can't be B. Can't be here, but so it's one of these 3. But that doesn't really help us very much, does it? Ugh. This is the very hard part of this puzzle. I really like the logic, but then now we're just, I don't know, just like we're just trial and erroring things. Which is not very fun, actually. C, okay, so this is a 9C pair. Okay. So B, again, cannot be part of this set. Can C. This can't be 4 or 8. Right, C has to be one of these 3, so C has to be one of these 3. So for C to be part of red, it's either here or here. And therefore C also cannot be on this set. So we cannot have 4 or 8 here, which means we have a 6 here and we have a 3 here, which eliminates 2 as a possibility. So this becomes a 1, 3, 6, 9 combination. Interesting. That means this can't be 6 here. Sorry, this can't be 2 here because the 3's on this Nabner line, which means 2 has to be here. So this becomes a 2-7 pair. That eliminates 2 and 7 in the rest of the column. Where is the 6 in box 3? 2, it has to be here, which means this cannot be 6 here. That means this can't be 6 here. This is 9. That means this has to be 6 here. 9 eliminates 9 here. So this is guaranteed to be C here, which means we do not have a C available for the blue. We have to have a C available for the red. This can't be 9 here. So C is there. This must be 9. Okay, finally. That means 9 cannot be here. We're guaranteed a 9 in one of these 3 cells. This is C. We have a 4-8 pair in column 6. This 1-3. Well, where's the only place for 6? It has to be there. This is 2. This cannot be 9. So Z is 1 or 3. And it has to be here. There's no 9 here. X and Z are both here. We have a 1-3, 1-3 pair in column. Oh yeah, 9 had to be here. That's why. That leaves X as 9. Z has to go here and then there. And therefore, this is 9. So we have B and C here. That was pretty complex. Anyways, we have a guaranteed 9 here, so this cannot have a 9 there. This is C. C cannot be here. It's one of these 3, but we don't know which. There's no 9 here because of 9 in the column. No 9 here because of 9 in the row. No 9 here because of 9 in the row. This 1-3 pair eliminates 1 and 3 in the rest of the row. So no 1 or 3 here. No 1 or 3 here. Okay. We have 4-8 pair here, which eliminates 4 and 8 in the rest of the row, so this can't be 8. This is 1 or 9, 1 or 8. This is complicated. So we have a guaranteed 9 here, which means this cannot be 9 here. 2 eliminates 2 here. Whereas this is a 4-8 pair in box 7, which eliminates 4 and 8 in the rest of the box. So this can't be 4 or 8, it's 1. This can't be 1, 4, or 8, it's 2. That eliminates 1 in the rest of the column. This is C. This must be B here, so that makes this C here. So B is one of those 2. This is 7 and B is a pair, so this cannot be 5. It cannot be 3. We have a 4, 7, 8 triplet here. This can't be 5, so where's the 5 in column 1? It must be there, which makes that a 3. This can no longer be 3, so where's the 6 in this box? It has to be there, which forces that to be 9. That means this can't be 9 here. It's 1, which makes this 8 to be on the Nabner line, so this cannot be 8 here. This can't be 4 or 8, it's 9. So that eliminates 8 and 9 in the rest of the column. We also don't have 5 in the rest of the column. We have a 2, 4, 6, 7 quadruplet. Actually, we have a 2, 4, 6 triplet in column 9, which eliminates 2, 4, 6 in the rest of the column. So this can't be 2, 4, 6. It's 7. That eliminates 7 here and 7 here. And this can't be 4 because of the 2, 4, 6 triplet here. And this is guaranteed to be 4 now. So that eliminates 4 in the rest of the box. These are the same digit because these have to be different ones. Let's remove 5 and let's just remove those. So this is B, C, and Y still. That's fine. We have a guaranteed 9 here. This can't be 5. C cannot be here, so C is one of these two. So this is 7 and C as a pair, which means you cannot have 1 or 3 here. It's 4, 7, 8. That 4, 7, 8 triplet eliminates 4, 7, 8 in the rest of the column. So this is 1, 3 as a pair. That leaves this as 1, 3 also, because this is guaranteed to have a 9. 5 cannot be here. Okay. This is Z, this is Y. Y is here, so Z has to be here, which makes that Y. That leaves this as a 2, 5 pair here. 1, 3 eliminates 1 and 3 in the rest of the row. So the remaining digits in 1 eliminates 1 here. So this is 3, which makes this 1, which makes that 3, which makes this 1, makes that 3. 1 eliminates 1 here, so therefore this is 3, 9 as a pair. So this is 1. No 1 here, no 1 here, no 1 here. This 3 means this can't be 3, so that's 1, that's 3 there. This cannot be 1 or 3 because of the 1, 3 pair in the box. Okay, pretty complicated. 3 eliminates 3 here, so that's 4, which makes that 3. That means these can't be 4. 4 is guaranteed to be one of these 3 cells here. So where's the 4 in row 3? Cannot be here because we have a guaranteed 4 there. Cannot be here because we have a guaranteed 4 here. So B must be 4. That's not helpful there. So those are all 4. Let's remove B. Let's remove the C's also, so that we can get all the C's as 8. This can't be 4. Let's remove that aspect. Y. There's no 1 here. We can remove Y from this aspect. No 9. No 8. So it's 4, 7 as a pair. This can't be 9 because of 9 in the row. These can't be 3, so this must be 9 here. And this can't be 3 or 9. It's 1, 5 as a pair. 3 eliminates 3 here, so that's 9 and 3. 3 cannot be either of these cells, so where is the 3 in column 4? It has to be there. This can't be 4 or 9, it's 8, which eliminates 8 in the rest of the column. This can't be 8, it's 5. No 5 or 8 here. 5 would be consecutive with 4, so this can't be 4. 5 is consecutive with 4 here, so this can't be 4, it's 2, which makes this 6, which makes that 2. Therefore, that's 4. 2 eliminates 2 here, so it's 7 and 2. It also eliminates 2 here, so it's 5 and 2 there. 7 eliminates 7 here, so it's 4 and 7. 1 eliminates 1 here, so it's 5 and 1. This can't be 5. 9 eliminates 9 here, so that's 7. 8 eliminates 8 here, so it's 9. This can't be 8 or 9, it's 5. This can't be 7 or 9, it's 4. 7 eliminates 7 here, so it's 8 and 7. 8 eliminates 8 here, so it's 4 and 8. 3 eliminates 3 here, so it's 1 and 3. And we're doing all of this by Sudoku. This is 8, this is 6, that's 1, and this is 9. Oh, dang, that's hard. That's a lot of very unintuitive logic there. Um, yeah. I felt like it was like two completely different puzzles. One was trying to figure out what the long Nabner line was, but the second one was trying to figure out how to just solve the rest of this puzzle, right? I mean, given the constraints of the Nabner, that was yeah, that was a doozy. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.